die woont hier in Amsterdam. En dat kunnen we dus...
Ja, zeker. Ja, dat is een echte hacker.
Special first DBpedia community meeting. My name is Enno Meijers. I'm working at DBpedia.nl, which is an organization who is building the Dutch public library infrastructure. And my company has been supporting the Dutch chapter of DBpedia for the last 2 years. I'll keep this very short because we have a very busy and very interesting program, I think, and I can't wait to actually start with it. But before we do it, I want to use this opportunity to thank a number of organizations. First of all, of course, the Vrije Universiteit for having us, for providing the facilities for him. And also the Koninklijke Bibliotheek and the Semantic Web Company for providing all the food and drinks during the day. But most of all, I would like to thank the University of Leipzig and the OpenLink software company for maintaining the DBpedia and putting all the good work that has been done over the years now. So I'm very grateful for that. If I just make a personal remark, I'm working at public libraries, and libraries are on earth to provide access to information and knowledge for the people, and do that in an open and easy way as possible. That's our goal. And at the moment, if you look at DBpedia, Wikipedia, Wikidata, Europeana, Digital Public Library of America, those are all initiatives for public information infrastructures, and I think it's very important that we all work together and find synergy between all these developments and see how we can do smart things together. And I hope that we have a lot of ideas for today to start working more and more on this. This is basically all I wanted to say, and I hope you have a very nice day and have a very inspiring day above all. Thank you.
Okay, thanks. Is this working? Never mind, I'll just talk louder.
I think you turn it off.
Yeah, I switched it off, sorry.
Maybe now? Oh,
Yeah.
yeah. So first of all, I would like to thank all the people that, well, let's say these are our sponsors, and they helped us to organize the coffee and the lunch, especially the National Library of the Netherlands and the Semantic Web Company. And also I'm very thankful to Laura Arroyo and Victor de Boer, who organized the rooms from the Vrije Universiteit. So I just wanted to say thank you that we are all here and have some coffee and hopefully lunch later. So now I will start with my presentation. So yeah, my name is Sebastian Hermann, and I'm from INFI at University Leipzig, so the research group is called EKSW, and I started my PhD there in 2009, where I worked, actually you could consider me as the second generation of PhD students working on DBpedia. So there was, before me, there were people already working on it, and then I took it over for a year or so, and then other PhD students started to continue working on it. And since then, since 2000, so I also met the master student who originally made the first extraction of the data. So originally this was a master thesis, which then got taken up by Free University of Berlin and also OpenLink. Okay, since then, of course, it has grown quite a lot. So this is still the image of September 2012, where you see the DBpedia dataset in the middle and with all the links pointing at it. I think you're mostly familiar with DBpedia, so I will not give a big introduction. Now, one thing, of course, at the moment we are extracting a lot of information already from this page, like the coordinates or this info box part. But there's still, I think, a lot of let's see, a lot of room for improvement, especially in 2 dimensions. So one is to have some kind of quality control. To really make sure that you get the right kind of information out of it. And then there's the huge part in the middle, which is the text, which is not, at the moment, not really, it's only partially analyzed. Show a short the result of a Google Summer of Code project, which is a new interface for DBpedia. Because if you know the old interface, it's basically the light green and dark green, and it's not very pleasing to the eye. So at the moment we have this installed at the Dutch DBpedia already. And what you can do is you can type here, and then it shows you, it filters the triples while you type, and it provides triple actions here, and you can add your applications here. Like this, for example, is the rel finder, and then it will load the object automatically, the subject Amsterdam and the object automatically in the rel finder, and start to analyze the relations between the 2 elements. So I just wanted to give a short update about what's going on. Recently we started also to make these images which provide a bit of an overview of what kind of data is available from DBpedia. Because the documentation is available, but most of the time, so yesterday there was the pilot meeting, and I talked to a lot of people there, and they have difficulties to get an overview or a right introduction to the data which is available via DBpedia and where it comes from. So we kind of like try to create overview images now, so people more find the right information they're looking for. And on the left side, we included also a community-generated content, which comprises the DBpedia ontology and also the mappings wiki, which a lot of people have helped to create in the last years, which improve the extraction rules. And also, and my colleague Dimitris will talk more about this, there is a community which tries to which is becoming more and more international and trying to analyze the individual Wikipedia language-specific editions. So here are, I think this is was automatically generated from DataHub, and it shows the links in between the Japanese, French, Dutch version, which are where this is just an image of where the meta information is available for the different language-specific versions. So it doesn't even reflect the actual data that is there. And now, because my talk, if I go back, is the DBpedia project in 2014, and so the subtitle is From a Hosted Dataset to a Public Data Infrastructure for the Web of Data. So, and what I want to say with this is, if you find a bug somewhere, the question is always who fixes it. And we discussed this yesterday, and actually I myself wouldn't know this answer probably. So there's maybe you just have to write an email to the mailing list, and maybe it gets forgotten, or maybe somebody records it, or if you're lucky somebody fixes it. But at the moment the DBpedia has more a pay-as-you-go model. So basically you need to find somebody who has an incentive to have the bug fixed, and then he has to do it himself to improve the data. So, and it basically comes down to the question between research versus development. So DBpedia is an excellent, I think it's a very excellent for research and a very good research project. And researchers in general, they are frugal, so they like problems and hard work. And they will also, so if they encounter a problem, they kind of like try to solve it from a scientific perspective. And also the papers which are written about DBpedia receive a high number of citations, and there is a high number of research contributions using DBpedia. You can see this. I always test it like this. You can make a site search in Google. So this is outside the domain of the semantic web. This is the Language Resource and Evaluation Conference. So this is a natural language processing conference, which has no semantic web technology at its core. So if you search for DBpedia in the proceedings, you will find 23 papers in 2012. So this is one sign that it's going out of the semantic web community into other communities. So maybe yeah, of course there are conferences like Semantic Web and Library as well, and so this is spreading. So DBpedia is becoming well known beyond this. But I think that DBpedia is not yet fit to bridge the gap to development. So normally developers, companies and organizations, they are quite picky, and they also think economically. They think in the terms of, is it worth the effort? Or if they think the data is not of high quality, they will ask, can we use something else immediately? And there's this word wrap here, where I put things in which are important for companies or organizations. Like you need to have you need to know about the coverage of data, the validity, you need some support, data quality is important, convenience of access, that there's off-the-shelf solutions. And I really hope that in 2014 we can finally emphasize also the development part and move dbpedia.org, basically I put this there from http dbpedia.org to something called the DBpedia project. And I would say that we use maybe 2014 as an incubator for a not-for-profit organization who kind of like consolidates the community effort in the same way that Wikimedia supports Wikipedia, the Wikipedia community. So now actually I charted down some goals of this DBpedia project, but it's not only me who's to say where this project is going to go. So if you find this during the day, see we made for each session we made a notepad in the program, and you can click on it, and then you can go here, and I charted down the goals of the DBpedia project just to have a brainstorming. And if you are on a laptop now, you can go there and add your ideas, and I would encourage you to do it. I will read the ones that we came up with the brainstorming. So one goal is to extract structured data from all available content created by Wikipedians and other open data projects in all languages. Then uphold a free public data infrastructure to exploit this wealth of data. Support the linked data community, and in particular, of course, the DBpedia community, to keep clean, publish, enrich, and interlink their data. Move from research onto development, and bring together publishers and consumers. So is there anybody who wants to, shall we have a question around here, or yeah?
Yeah. Are you thinking of also putting microformat or RDFA in the Wikipedia content, so it can be extracted as well, or is that part of it, or am I saying something really foolish now?
No, we should discuss this. I think a lot of people want to discuss this. Let's say. Maybe like this. Yeah.
Yeah, and what's the relationship with Wikipedia?
Oh, that's the next presentation. Here's the real. So here, there's Wikidata and DBpedia. Yeah, maybe during the day, feel free to add more goals here. What's important for you? Yeah, I'm almost done. So one more thing. So there in September, there will be a huge conference in Leipzig, which is called the Semantics. And it's called the 10th International Conference on Semantic Systems, which was formerly iSemantics in Graz, so most of the people know about this. And I'm having a major stake in organizing this conference. And the main part are transfer, engineering, and community are the main keywords for the conference. And I hope that I would offer to co-locate the second DBpedia community meeting on September the 3rd with this meeting. So just because it's, I think it's a good opportunity. Okay, I'm almost done with my presentation now. So let's look at the schedule for today. In the first two sessions we have presentations, which are straightforward, and I would encourage you to use the Etherpads, put questions there which can be answered later as well and serve as basis of discussion, right? So at the last workshop we made it like this, that you record questions there as well, and then the presenters answer them after the presentation, or a day later or 2 days later. So nothing gets forgotten really. And here, if you look at the breakout session, each of them also have a notepad, and I would encourage you to look right now at the different topics. Look where you want to go. Open the Etherpad, right, and start typing topics, talks. Add yourself to the participants, so the session chairs can really plan a little bit ahead what they're going to do during the session, right? And you can also contact them. They're all here. Yeah. Basically, that's it. Thanks.
Hi, I'm Dimitris Kodokostas. I'm from a KSW group, like Sebastian. I'm the third or the fourth generation of PhD students in DBpedia. Today we're going to talk about personalization. Before we go into details, let's look about the mappings wiki. Most of you might not know it, so it should be good to give you an idea of what we do. Structure in Wikipedia. Although Wikipedia looks like text, there's actually structure there. We have title, coordinates, categories, links to other languages, links to pages, links to external links, external pages, redirects. But the most important information we have is from info boxes. If we look in the source code, we'll see a semi-structured data like property value thing. And at the beginning, what we did was we took a greedy approach. And for every property, we create a new triple. For example, for title, we create a triple for the page as a property and then the value. However, this had some problems because, as you might see here, we have three different info boxes. One for an actor, one for a musician, and one for the prime minister. And they look quite different. For example, if you look at the born date, born information, they're not exactly similar, the two of them, and prime minister doesn't have a birthday. Yeah. The occupation is also different. Here it's like a title, and in the other is occupations, and here is occupation. So when we extract triples in a greedy way, we don't get homogenized data. Properties are different, so we can't query our data efficiently. Now, here in the source code, we see that the born in the musician is actually a date with place, while in the actor is birth date and birthplace separately, or in the prime minister is birth date and birthplace with another score, which gives another level of variations here. But what we can say for sure, in most cases at least, is that when we see an info box about a musician, we know this page is about a musician, this is about the prime minister, and this is about an actor. So this is how we classify articles in Wikipedia. About to homogenize the other data, what we do is to use the mappings wiki. If you have a browser, you can go there and open it. It's mappings.wikipedia.org. Everyone can contribute. We already have a lot of editors, but all are welcome. What we do is provide correct semantics to combine what belongs together. For example, we birth date with underscore, birth date with underscore, separate what's different, which gives a big boost for precision, but recall is crowdsourced. Yeah. A simple example to give you an idea. For example, we have the info box about the album of Nirvana. What we do is, in the mappings, we say we map this class, the album class, and for every property, we give an ontology property. For example, the name, we give both name, the last album, previous work. So we have an ontology, and we map every property of an info box to our ontology, and this is how we clean up the data. Okay, that's it for the mappings wiki. Now about the internationalization of Wikipedia. It is actually an effort to port local non-English Wikipedias to Wikipedia. Why? Because most local Wikipedias provide information that English Wikipedia doesn't. For example, the French version of Eiffel Tower is better than the English one. Articles of local importance might not exist at all in English. At the beginning, 2007-06, I think, legal extraction was limited to basic extraction only on labels, categories, and links. 2009, Korean and German started the first effort to internationalize the framework. It was based on the PHP framework. In the 2010, the Greek Wikipedia extended the new Scala framework, and then many languages followed. Now things are much better. Default extraction is enhanced, and for some languages we have tailored for even better extraction, which is first either to more mappings or extractor tweaking. Some statistics. The first version that was internationalized is 3.7 DBpedia release, which introduced language-based namespaces. Not all of them are dereferenceable, but some local chapters provide this facility. The latest one, 3.9, has data in 191 languages. That's quite a lot. Mappings are enabled for 28 languages, 24 are quite active. We have 15 local chapters, 12 are from Europe. We have Indonesian chapter, Japanese and Korean. Japanese and Korean are actually here today. What the chapters do are they provide referenceable URIs or IRIs. They have their own community, they manage their own domain, and they coordinate the mappings creation for their language. Now about the mappings wiki again. We have the Greek info box for a book and the English info box for a book. And what the mappings wiki actually does is map all the data from different languages to the same ontology. So this way we have a consistent view of all data in all different Wikipedia language editions. So a query we do in the English Wikipedia that's based on the author can be answered both in English Wikipedia and both in Greek Wikipedia or Dutch Wikipedia. Which is very important why the mapping process is critical. Some statistics about the mapping activity. The Maps Wiki does two things. One is we crowdsource the ontology. We create the classes and the properties in the Maps Wiki. This is shown here. At the beginning we had a lot of activity and then the ontology is somehow stabilized. And here we see the mapping per languages. At the beginning we had only English mappings and then a lot of languages starting to follow. We have a lot of activity ever since. Yes, some statistics about map templates properties. English, for example, has 300 template mappings and around 6,000 properties mapped already, which compared to the total number of properties and templates is quite low, but if we look at it at the percentage, because we follow a lot of properties are used more often, so when we map certain properties, we got a high percentage of coverage, which is quite high for most languages. This is for map templates and this is for properties. Some statistics about the 3.8 release. This is a little bit old, but this is what we had. It's about number of instances per person, place, organization, and work. Okay, the Dutch people might wonder where is the Dutch Wikipedia here, but it didn't exist at the time. And although it's only 1.5 years old, it's done quite a good job already. Yes. Now, this is the key point of all the registration process. We focus only on these two columns. The first is the number of instances that each DBpedia provides. For example, the English has 3.7 million articles, the Dutch 1.2. This table shows how many of these articles are linked to the English version. We see that about 30 to 50% of each language does not exist in the English Wikipedia and Wikipedia. So this effort is, needs to be done because we lose a lot of data if we don't include local languages. Another interesting statistics about how many instances are occur in more than one language. We see that around 4,600 persons are existing more than 10 language editions only. So, okay, that's it for this. You can go to this link. It's more information on read these two papers. We have details about the images we saw before. Before I close, I'd like to mention about the Google Summer of Code we did this year. We had 5 successful projects. One was type inference based on categories by Casul Pereira. The code is available on GitHub. New interactive Wikipedia interface, Sebastian showed before. It's available on live.db and on Dutch Wikipedia. We had the first version of our Wikidata integration. We plan to have a live Wikidata Wikipedia endpoint sometime this year, hopefully. power tool for DBpedia testing and metadata by Lazarus Ioannidis. I'll show you one slide about this later. And for Spotlight, we had it in generalization format. If you know any students for this year, we'll apply again, so tell them we're interested. Now about quality at DBpedia. We plan to deploy this soon. So we have a tool called DataPacker, and with Google Summer of Code project that Lazarus did, we create particle quality queries to locate errors in DBpedia and Wikipedia. So we have persons with more than one birth date, for example, this is the query, and we get a list of people that have more than one birth date. And if you see this article, for example, you see that the Wikipedia page had an error, had 2 dates for this one. So this way we can go to the source and fix the errors and then get data improved. What Lazarus did actually was an interface where you can browse and navigate through all these errors through basic browsing. So we create a lot of tests and then we load them in a Spark endpoint, and then people can go in, find the errors either in, and then go fix them. So quality will improve. That's all. Thank you.
Any questions?
I've typed them already in the note. First of all, is there a WikiCat for the mappings? Because it's so easy to think this is this, but often you're wrong, and then you need a community to correct you when you're thinking something wrong, right?
Can you repeat?
Is there a WikiCat? On Wikipedia we have a WikiCat, you know, there's always a facilitator who looks at your change and then decides whether it's a correct change or not.
We have many editors already, so someone will correct your
Okay,
errors.
okay.
It's like
but-
Wikipedia. Yeah.
okay,
It's not
but-
so big community, but yeah, we have a community that.
Okay, but on Wikipedia there are facilitators and they have a WikiCat. So rules, what you should, for example, you cannot relate a Dutch Wikipedia to a page to another, to an English Wikipedia page. It's not allowed. I didn't know, but it's in the WikiCat. And that kind of stuff. Is
We
there a
have some
WikiCat?
rules there you can read, but yeah, it's not so strict here.
Okay, okay. And I have one more question. Okay, what's the name? Because this testing that you're doing is really, really exciting, and not just really only for DBpedia. Do you have a name? Is there a community who thinking of these tests? DataPacker?
DataPacker is a tool that creates. Yeah.
Okay,
Look
but it's
around,
also a
find it.
community.
No, it's not a community. We develop it in Leipzig, in
It's just
HSW.
2 people.
It's more, yeah.
Yeah, but the point is, when a tool gets created, it can be used. And that's the most important thing. Building tools is great, but having them used is even better. So, and that is basically what, as far as I understand, DBpedia is about. It is all these different academic processes or projects and what have you. And at some stage they all bring together their expertise, their data sets and whatever. It comes together in DBpedia, and that makes it the high quality data that it is.
Okay, I work at the tax office. I'm interested in quality data, right?
Right, yes. Yes, and I use things with Wikidata, and we do things differently, but we could learn so much from the DBpedia, and basically getting cooperation and have their community join our community, that would be awesome.
Okay, how do I do it?
Now, well, listen to my presentation.
Okay. I'm all ears.
Anything else?
I'm reading the images. I see there is one error, so-called error, when somebody has 2 birth dates. It may be possible that it simply is not known. How do you?
Yeah.
How do we?
Birth dates from Turkey. Yeah.
Yes, for instance, yes.
Yeah,
we need
this
to-
test
yeah.
finds double dates. We have another test that finds
Yeah, so we need to
existing ones.
adapt the ontology in order to accommodate with that problem.
But one of the big problems with birds of dates and birds of deaths, you particularly find here things like Islamitic dates. They use a different calendar, and
Okay.
the calendars of the Islamitic year don't map onto our years. So when you see that somebody died in a specific Arabic year and he's from an Arabic-speaking country, then you can bet your ass that the date that you find in English Wikipedia is wrong, and it's the Arabic one that's used. It's that kind of thing where you basically need, where you are happy to have multiple dates, but you need a community in order to pick the right one.
So in this case, it was had two templates, one person date and the plane that had the wrong date, and then folks template had another date. It could not this case,
But actually, in this case, this test is generated from the DBpedia ontology.
Yeah.
So maybe we could go to the DBpedia page and show where this can be edited. Because it's a restriction, this is a constraint which has been provided by the community, right?
Yeah.
So I don't know if we switch. Always good if we showed once where to edit these constraints, right? Yeah, this is for. So now you.
So this is all functional property, which means that if it occurs, it can look only once. So this test can be automatically generated based on the ontology.
Yeah, so
create this query automatically based on this rule. You can find all.
So we need to introduce it like called something like approximate date.
Yeah.
What? Yes, sir.
So I didn't understand.
Well, we need to enrich the ontology with the class, for instance, like approximate date. Or, but that's too much detail already.
yeah, it's difficult. Like functional properties are really difficult if you
Yes,
have
I know.
other.
Deal with it.
Yes, true. We use a rekendatum because the moment you turn 65, we need to know that. And the Arab people indeed they have 0, 0, 0, 0, and then only a year, and we turn that immediately into 1, 7, and then the year. So because we need a rekendatum to translate it into, we need to know the moment you turn 65, or the moment you turn 18. We need to know.
Maybe Patrick, yeah.
I don't have a
Introduce them
for
properly.
you, but most of the graphs that I will be talking about are in the publication. So can I borrow your? I forgot my phone.
Ah, okay.
Yeah, I forgot.
Might not be a bad idea. Might not be a bad idea. Everybody knows everybody. So
Okay.
it's good to hear where the stories come from.
So I'll introduce Patrick van Kleef while he sets up his route. Patrick van Kleef works for the company OpenLink Software, which was one of the 3 partners to join in the beginning when we set up DBpedia. It was the company has provides a database, a graph triple store, which also open source version, and they took over the hosting right from the beginning. So, which was why actually I think DBpedia was one of the first data sets who was available as linked data and was available as a Sparkle endpoint. And since then they have provided this hosting for the public endpoint. Which also means that they have also collected a lot of log files, which I think that the talk will be about, and which also can be analyzed if you are a research, if you're interested in this. Yeah, what else is there to say? Well, you should continue now, Patrick.
Yes, he will play. So, Can anybody hear me like this, or should I use the mic? I'm looking at the back people. But, yeah, it's okay. Bit easier to do it like this. Yeah, thanks for the introduction. I'm from Opening Software, and we have written one of the main databases that deal with triple stores, and we host the DBpedia dataset. We've been doing this for some time, so at the starting point we had a slightly smaller machine with only a couple of processors and only something like 24 gig of this is yours. 24 gigs of memory. At the moment we're running on a 8-core machine with 64 gigs of memory, and what's happening? Yeah. I'll do it. I have my presentation here.
Yeah, you can open the Etherpad. We can put questions there.
Yes. Okay, so Virtuoso has, first of all, in the beginning we saw this big picture of all the linked data sets with DBpedia in the middle. That one is the one that we host. There's also a number of international chapters that host their own version. They do that in Virtuoso as well. But the statistics that I have created and that we have published in a paper that we did recently only deal with the main international version of DBpedia. At this time we are going through a change. Up to version 3.8 we were using a version that was a setup that was a commercial setup with 4-node cluster, which is not available in an open source form. As of the current version, DBpedia 3.9, we are actually running on a single database, which gives us the same performance as we had before, but also gives the community the possibility of duplicating basically what we did for the international chapter and have a similar kind of performance and quality of getting the data out. At the moment, DBpedia is doing around 1.7 million requests a day. That's something that you don't see in this big picture when you see all the interlinking, because nobody publishes, or not too much linked databases yet publish this information in a form that you can actually compare what's the uptake, how many people are actually using it. We have started since a couple of years to provide this information, and we will continue to do so. We did this in the research paper we did recently, and we publish this also from OpenLink ourselves each year to give an idea of accountability on how much is this actually being used. As we can see, well, you can't see it, but there has been a great uptake in the use of DBpedia, of course, over the last couple of years. In the beginning, like in dataset 3.3, we did about 800,000 requests per day. As said, at the moment, we are doing 1.7 to 3 million on a daily basis. This fluctuates, of course, because there are sometimes research projects going on where a lot of students make requests. There's other times where it's a little bit quieter, but this is about the scale on which we are talking at the moment. When we look at the data, we can see that there's also a lot of misuse, and in the sense that a lot of people don't know what exactly they can do with it, so they'll just try anything, query everything, try to relate everything with everything. And so there are specific constraints within the DBpedia system in the Virtuoso database that limit the amount of queries people can do per minute, the amount of time that a query can take in execution time. So this means that when you're using DBpedia, there could be times when you get only a partial result. Yeah, there are specific codes in the HTTP response structure that will tell you when this happens. The problem is that a lot of people that use DBpedia do not look at status codes. This is unfortunate because it gives a lot of information on whether you actually get your all of your data or you get a partial result. It also happens that when you hit the system too much and you hit one of the rate limiters, people just continue. And so there are extra precautions in the system to limit the effects on the general public when these things occur. Now, that sometimes it requires a little bit of tweaking, so it's not always immediately that it will improve, but we are trying to keep this up as a system that everybody can use. However, there are situations where researchers say, but I need to do a set of queries. They are very complex. I don't want to be hit by a rate limiter. I don't want to be hit by, I can only execute a query for so many minutes, or my result set is bigger than a certain number of rows. In those cases, what we do is we provide images that you can use on EC2 directly. You can start an image on EC2 and you basically get a complete DBpedia set with all the software, all the setup done. So the only thing you then need to do, you start it, and you have your own endpoint. That endpoint contains the exact same information as the main DBpedia, and any data that you get out of it will be dereferenceable directly to this central version. This means that you can do any type of querying, you can do any type of analytics on it without being struck by any rate limiting or without any other constraints, and still have a data set that in the end results can be published and people can see that and they can immediately dereference these RIs to the main data set. Don't know whether people are actually interested in some of the statistics. I have a document which I will share later, which has all the graphs and the various classifications. There's one thing that I want to do before I take your questions. DBpedia is a database or a system which can be queried in a number of forms, and some of us only see DBpedia as a SPARQL endpoint, but actually we host a number of different ways of getting to data. First of all, when you have an IRI, when you have a DBpedia resource /Amsterdam, yeah, when you go there with a browser, you will get this page. It's the standard one is the green page, and hopefully soon we'll have also the interactive model. But the main thing is that when you do this with a browser, you automatically get to a human readable page. When you do this with a web service, and you tell it that you want it in a certain format, being JSON for instance, you get immediately the data back in JSON format. Yeah, this is done automatically. There's interlinking also in that area, so when you read the page, you also get information on in which other models this data is available. So this is a very important part, and part of the statistical analysis that I did was to actually show the difference between the usage of the resource-based endpoint, so the dereferenceable endpoint, and what happens on the SPARQL endpoint. The Sparkle endpoint, of course, is also very much used. There's a lot of people who sometimes don't even use the normal IRI dereferencing, but just say, well, I want this data, so I'll do a Sparkle describe of this data. It's exactly the same what would happen if you took the direct IRI route, except for the fact that, yeah, some people, they then think that, okay, if this is the way, then I'll use that. There's a third option which is not very highlighted in things. There's also a faceted browser. With the faceted browser...
2 moments.
2 moments?
2 more minutes.
Oh, 2 more minutes, okay, sorry. There's also a faceted browser, and that's a way, if you don't know exactly what's in there, or if you don't know exactly what kind of properties there are, what you can do is you can use the faceted browser, type in the name of a keyword of what you're interested in, and then you get a list of articles. It does a free text search on the article list, which is very handy to have. You get a list, and from that moment on you can then start seat of the pants, clicking to see, okay, what are the properties, and then start making constraints on those. In the end result, you will learn something about the ontology without having to read anything else. You will learn about the ontology, and you will be able to get to much more of the data, and then also find out, okay, wait a minute, how do I then use this in my own Sparkle? That was it for now. So, any questions?
I understand that you have those graphs and information in a digital format. Can we have that, please? Because I blog about these things, and I want to. This is one of the things I want to know how much DBpedia is used, and
yes.
If I can blog about it, then
yes,
it's nice.
I will.
Have a paper.
We have just submitted a paper where a lot of this information is in, and so I have the data here, but I would rather that you take it from there and then cite us. So.
Yeah.
Anyone else?
Put the link in the Etherpad for this.
I see no raised hands, so thank you for your time.
Do you need help setting it up?
Yes.
Maybe could you do this? Your laptop's still there.
I'm going to talk about. Can you get that one? I'm going to talk about Wikidata now. Wikidata is only 1 year old, so it is very immature. Compare that to DBpedia, which has been along for so many times that you're talking about 4 generations. Does it work? Yeah. Okay. Yes, so let me go to DBpedia is already old in the sense of that it's talking about having people working and them being so many generation. With Wikidata things are different, as in it is intended to be used and to be used by Wikimedia Foundation projects. So the first reason why they wanted to have something was because the way we worked with inter-wiki-links, which are the links to articles in other languages, was totally crap. It was really horrible. You couldn't really manage it. If somebody said this name is no longer part of the inter-wiki-links and took it away, a bot will come back and put it back again because there were these other 300 and what have you wiki links that said no, there should be one, there should be one. So everything got into one database, And from that moment on, we knew about basically all the articles in Wikipedia. That was one big reason why we wanted to have the Wikidata, and the other one was we wanted to have to reuse the information in Wikidata in info boxes. So where DBpedia says there are the info boxes and we get the information out, we say we have the data and we get the information into the info boxes. Completely different way of doing it. The important thing is, when are things going to be used? Well, we at this moment in time we have 280 Wikipedias, so we have 280 inflection points where they say we are going to use data from Wikidata for our purpose. So what you see is that slowly but surely more Wikipedias are using information that is in Wikidata to provide information in the info boxes in their languages. And consequently, DBpedia will find more and more and more that data is actually coming from Wikidata. But the quality of the data, that is not something that is really too much to say about. Anyway, my presentation. So, it's the Wikimedia project for structured data. It's intended to be practical and to be used, and it's used a lot already. Info boxes and into Wikilinks were the primary targets, but we're now already doing things like Wikisource, Wikivoyage, and Commons is in the data that we connect to. So that means, for instance, that if you are thinking in terms of horse, we have a category in Commons about horses, so you can go from Wikidata in almost any language with the word horse, go to the category of Commons and find all these pictures of horses. You don't need to know English, which is the typical interface for Commons. So from that point of view, you can appreciate that this approach will make a big impact, because there are all these languages where all these kids of 7 years, all 8 years, want to have to work their project, and then it has to be about horses and kitties and doggies, and of course dinos. They are also quite popular. Now, if they can find, type in dino in their own language, can find the Commons link to their favorite dino, then they can have the public domain or freely licensed images that we provide of all those contents. Really important. Again, it is there to be used. One thing that is really important, and I will show you the statistics in a moment, every language does not cover 50% of all the items in Wikidata. For your information, an item is a subject, whatever word you want to use for it. All Wikipedia's articles could have a Wikidata item. That is not the case. When people create an article, sometimes they'll add them to a Wikidata item, but sometimes they don't. So there are lots of Wikipedia articles that are not linked yet. Now, we are having bots run to cover that, so you will see the number of articles, of items in Wikidata grow, and you have to appreciate they are not linked into anything yet. Statements is basically things like Amsterdam mayor is Eberhard van der Laan, I think his name is. Anyway, the point is that's what we call that's what statements are, and most items have one or less statements. Now this means that for most items we don't know anything about them except for their existence. So that's basically for you to understand where we are with Wikidata. What we also do is, let me ask a question to you. How many of you have published a paper or something like that? How many of you are in things like, what was this called, ORCID, or the thing from Elsevier, or how many of you are in a resource as a scientist? Okay, Now, the point is, if you have a Wikipedia article, you could be in Wikidata as well, because we allow people, external sources to be associated with items like ORCID. I have, for whatever obscure reason, my own entry in Wikidata, and believe it or not, I have an ORCID ID, and so it's there. But if you want to, you can just add it, and it is not that you have to, can't do it for yourself. We are not that fussy in Wikipedia. We have really informative statistics, and I will show you them in a minute. But when you look at Wikidata, it's not informative. There are many statements. It is, yeah. We have a tool called Reasonator, and I'll show you about that in a moment. And that does a good job at that. Wikidata is developed in Germany, not in the United States. And that has its own political issues. But then again, it means that the people of DBpedia and Wikidata are even geographically not that far away and that far apart. So that is another incentive for people to collaborate, to talk, because even the language is the same. Relevant is that our community in active users is at this moment in time number 5. So we are really having an impact. People are reading, doing things, and we have over 1 million new statements every month. So we are growing nicely. All recognized languages may be supported. That does mean that if a language does not have Wikipedia, like Ottoman Turkish for instance, that Ottoman Turkish can be included in Wikidata, so we can start collecting items in Wikidata. So if somebody is interested in, I am really into Ottoman Turkish and I want to have all my information in Ottoman Turkish, they can. It takes all sorts. If you want to do it in Klingon, by all means have it in Klingon. There's one thing that is important, and that is the bottom one. The community decides on the continued existence of properties. So we had a property, and that was associated with how the GND, that's the German National Data, whatever, decided to rank things. So they had people, and you had all these things to be people, and you had organizations, and it was weird and wonderful. And at some stage, and at that time we had already something like 4 or 5 million items with that statement. Our community said it's bullshit to have it, and it's basically being decommissioned. So do understand that Wikidata is not by definition a stable environment. By definition. Doesn't mean that things will change for the worse, but you have to appreciate that things can change and do change. We are immature, I said it before. Okay, Reasonator. Now that is something that I really love, because it's one of the things I am involved in. It does visualization of Wikidata content, and let's be simple, I'm going to show it straight away. Okay. This is a page in Reasonator of Mahatma Gandhi. And if you look at it, it looks really brilliant. I can't read most of it. For instance, I do know that that's Mahatma Gandhi. This is English, but do you know? Can you understand? Do you read it? Anyways, it is visual. It looks nice. And if I do something like this, I get a nice pop-up with the name of the person, the identifier in Wikidata. You can click on it, so you can go to the Reasonator information for his wife, because I happen to have seen this picture before. You can go to the Wikipedia articles, you can go to the comments categories. This bit is generated automatically. So this is done based on the statements that we have about this lady. And this is a static description. So whenever there is a picture, an image associated with a person, it will be available, and in Reasonator it will be available for every person. you can imagine that this has nice applications and that it makes it easy for people to get involved with something like this. And if I want to change this to, let me see if I can get this to work. I think so. So now we get him in Russian. Oh, and people like signatures, so we have signatures. I just mentioned about external sources. Here you have external sources. VIAF is an important one. And one of the sponsors is the Dutch National Library. They know VIAF, but as far as I'm aware, if VIAF doesn't have a reference to a person, we are quite happy to have the Dutch National Library identifier as well. So if we have the Dutch National Library identifiers associated with people, then we can have it. If there is another favorite external source of yours, we're quite happy to have them as well. The point is, and that's a weird one, possibly for you, many of these have their ontologies and all kinds of other scientific thingies. So you can reach them through us from here, but as we have them as a field in our thing as well, basically you could in principle apply their ontology, and when you want to, just get the information out, because basically we know about these connections, and we are happy to be of use in this way. So that was Gandhi. Let me see. Right. Oh, I was talking about statistics. Let me. These are the statistics that you will love. These are the number of linked items in English. These are them in German. These are them in Dutch, etc., etc. It's a long list. That URL and the one that I'm going to show takes something like a minute or 4 minutes to run. But then you get the actual data as it is at this moment in time. It would take a few minutes. This is a nice number. 62.3% of the items that we have in Wikidata does not have a Wikipedia article. So don't think of Wikidata as being English or any language. We are not, and this is the proof. This is another nice one. This one takes a bit longer to run. You see that the number of items without a label is improving a little bit, but now we have 6,011,447 items with a label. That means that even though there is not an article, you can find it. Yes, please.
2 more minutes.
2 minutes.
One or 2 more minutes. Then questions.
Okay. So this is a species. It does not have a genus associated with it, and we have a tool to allow you to update it from within the resonator. We have more of that kind of good stuff. This is where you then look in Wikipedia what the genus is, so that you can do it. I'm not going to do it. This is a example of an item where we don't know an external source. This should go there. I can show you how to do that. I'm the person who's mostly doing that, by the way. Right. Yes, this is the where you can translate the user interface, and we have query. Wikidata has query. Now here's the fun thing. We don't use Wikidata to do that. There is this wonderful guy called Magnus Manske. He is a researcher. He does have an ORCID ID as well. And he has built some software that gets everything that is of value of Wikidata in memory in a proprietary format, as in it is specific to the way he has built it. It's not proprietary as it is GPL. And basically it allows you to really, really quickly get into all the data that is in Wikidata. It gets updated in something like every few minutes, so it is up-to-date information as well. You can have it too. You can update it from Wikidata in the same way as we do it. So that is basically telling you, researchers, that if you want to have up-to-date information that you can look at on your own systems and do whatever you like, we can help you with that, not a problem. And we can do queries, but this is where we put a query statement, but you can also do things like put here a category name, run it, and then put a claim on it. Which means that you can, for this whole list, 50 times at a go, you can say, okay, tell me that it is this species in that genus. You can do that, we can do it, we have the tools. So we are really working on making it quickly, but the key thing is, what we have is a lack of quality data. It's not good, it needs a lot of improvements. And it would be wonderful when the DBpedia technologies and communities would work together with us and bring the best information to all the people in the world. Because sharing the sum of all knowledge, that's what we're there to do. Thank you.
Thanks.
Yeah, we still have time for questions, so.
Question. You talked about these identifiers for, let's say, via identifiers.
Yes.
What would be the proper route to get the Dutch TPN numbers into Wikidata? Is there an option for bulk loading these kind of data? Or?
There are people who are doing it all the time. So if you have, if you know the Wikipedia article and you know the identifier that you want to upload, given that the identifier exists, it's just a matter of running a bot. And you can, and you're allowed to. It's just a matter that it's polite to tell, hey guys, I want to do this, and then they will see. Yes, please.
Yeah, I'd like to know a bit more about the policy you may have for feeding into Wikidata. Because I remember like a while ago when the project started, it was kind of backed by the pages. So the idea would be that there would be data in Wikidata if there was corresponding stuff in Wikipedia pages.
We've gone past that point. The policy is more or less like this. If the information that you have is relevant, and there are some rules to relevancy, then you can include it. So, for instance, I've been working on a little bit on how do you call it? The king has a son, and what's the word for it? Sorry?
Lineages.
Yeah. Well, there was one that was not known that didn't have a Wikipedia article, so I just created him, made a connection, and now I can show with the tool, which is also in Resonator, how that all went. So yes, you can have things as long as they are relevant. Now with Wikisource, you have things like books, and books have things like issues. So you can have books and you can have issues. And now there is a conversation going on which books and which issues are relevant enough for Wikidata. And some people say it has to be a book that is available in Wikisource, and basically there is another group of people who say bollocks. It is not that if it is already relevant when the when the thing is available under a free license, so that everybody can use it. Because we want to share in some of our knowledge, and consequently we do a better job when we do include these kind of things. There are issues with that, like the self-kickers, the self-publishers, and all that kind of good stuff. But that's basically the kind of discussion that we have.
Continuing, so because you're telling that the relevance decide, but would you say that in general the idea of relevance is very stable, or the examples that you mentioned about the issue, they are kind of the rule and everything is unstable in the community?
It is very much unstable, and when you have somebody with a big mouth, and I have a big mouth, I grant you that, then you will find, I publish on my blog, so I blog about a request from India that that there is a resource in the Bengal language which has an awful lot of books, and they are all freely available. You can't buy them anymore. The libraries find that the books are crumbling, that kind of stuff. They did digitize them, and they want to get these books out. So from my perspective, that is the kind of argument where you basically tell people to shut up because there is hardly an alternative. Given the amount of people who speak Bangla in England, it is practically the only way in whereby you can really make some propaganda for those kind of projects. So I don't mind if it is in Wikisource, in Guggenheim, Internet Archive, a library system like that, if it is considered to be relevant on that kind of level, that is more or less institutional, but that gets rid of the self-publishing and self-righteous and what have you book writers, then that's what I would go for. Any other questions?
I'm just wondering, is there any ongoing discussion in Wikidata about upper level ontologies, or is it for now sort of a consensus we're not going to use any of those?
Well, basically there are two types of people.
I agree.
And well, from my perspective, there are the academics and the people who want to get things done. Now, in this public, I think that if I define academics in this way, it's a bit embarrassing, because DBpedia is very much about having an application, making use of it, getting the data out. So even the academics are in two kinds. So there goes my argument. I'm not an academic, really. But yes, there are people who are academic and they make long diatribes about how this can be self-referenced and what have you. And when you then say, but how does that work in an info box, then they basically don't have an answer. So from my perspective, having an upper ontology is fine. It makes sense to have them. But then you get into things like, is king the class, or is king of the Netherlands a class, or that kind of stuff, and how does that apply into queries? Or do you things like what we can do in Wikidata? Do you say Willem-Alexander, the Dutch king, king, and then a qualifier, country, the Netherlands? Those things are possible. We can do those things. But then you get into these fights where they say, well, we have this application and it's called this and it is really academic, and if we do that, it can't use it. It's that kind of discussion that we're having. And I'm firmly on the side of it has to be practical.
Yeah.
Thank you.
How many developers do you have in Wikidata?
Okay.
Sorry,
So
what was the question?
the question is, how many developers do we have in Wikidata? We have, as far as I'm aware, on the payroll, something like 7 or 8 developers who are working full-time on Wikidata. What they are working on is Wikidata as you find it on wikidata.org. And they are the guys who make sure that the basic product that they provide is without anything that has to do with the wikidata.org thing. So development and data is nicely separated and all that kind of good stuff. Then there are these other things, and there are loads of people, and they are spending lots of time on providing patches and what have you. They are the contributors, they are part of the community, they exist as well. Don't know exactly a number for that. For Reasonator, it's quite simple. We have one guy, he is magnificent. He is the original guy who wrote MediaWiki as well. So, what better credentials can you have? And that's one guy. And so that's basically what it's all about. And he is doing it in his spare time because he's actually working on the university in Cambridge. So I don't know how he does it. He must be brilliant because otherwise he's not doing his job.
Is it something like an editorial or monitoring structure or community like you have in Wikipedia for Wikidata as well? Or?
Yes, it's exactly along the same lines of Wikipedia, and it's funny. It has the same types of politics. I applied to become an administrator, and I was told that I didn't know the community well enough. Okay, that's fine. Yes, we have them. Any other questions? Okay, thank you very much.
Hi, welcome to my talk. My name is Joachim Deiber, and I'm a PhD student here at the University of Amsterdam in the group which works on logic, language, and computation, which is basically mostly machine translation and some logic stuff. And I'm going to talk about DBpedia Spotlight today. So I don't know if how many of you know DBpedia Spotlight, but it's a project that was started in 2011 by Pablo Mendes and Max Jakob and Chris Bitzer. And Sebastian said earlier on that you have this big blob of Wikipedia data, and the biggest part of it is basically text. And we are a project that tries to work with text. So what we're doing is we link DBpedia entities in natural language text. So there are a lot of things you can do with that. I mean, you could, for example, just use it to, if you write an article and you don't want to do the links yourself, you just run our tool and then you automatically get like the links. But there's also a lot of like research things that you can do with this kind of tool. The initial funding was mostly through Link Open Data 2, DICODE, and IKS. And in the last 2 years we had 6 GUI Summer of Code projects, and we have 4 maintainers at the moment, and more or less 7 contributors who are, well, who are more or less active. So let's have a look at an example. So what is it that we're actually doing? So here we have a text about Michael Jordan. So it's a text about basketball teams, and there are a lot of words in it, and somehow we want to know what this text is about and what kind of DBpedia entities are in this text. So there are basically 2 things we need to do. The first step is we need to figure out what do we want to link in this text. So we need to find the entities in the text. So here, for example, I marked all of the basketball teams in this violet color, and the people are in orange, and then NBA Draft is a DBpedia entity, but it's not entirely sure what kind of entity that is. But I mean, we don't care about if it's a person or a organization or anything. We are agnostic to that, so it doesn't matter what kind of thing it is. So how we do that in DBpedia Spotlight is there are 2 ways. There is one which is dictionary based, so we just create a dictionary of all the things we've seen in Wikipedia, and we run that over the text, and then we look at the probability that this is actually an annotation and throw it out if it's too low. And the other thing that we do is we use some language resources, for example, an identity recognizer or a noun phrase chunker, and using that we can also get some candidates for those. So now we know what part of the texts are DBpedia entities. Now we need to figure out what DBpedia entities are those. So this is what's called the disambiguation task. So if you look at the text again, here we're talking about different basketball teams. So there's Houston and Rockets and Blazers, and here, this one I'm looking at now is Portland. So now the question is, okay, this shouldn't be that hard. Why is it difficult to find the right DBpedia entity? I mean, we could just go with the most common one, which would be Portland. But as you see in this case, this would be actually wrong, because what we're looking for is the Portland Trail Blazers entity, which is the basketball team, and not the Portland, Oregon entity. So in this particular example, there are actually 127 entities which we have observed in Wikipedia to to be referred to as Portland. So you just go through the entire Wikipedia, and you look at the link texts, and you count how many, or you just select all of them which have Portland as a link text. And so now we need to decide which one is the right one in this specific text. And we had a few iterations, I guess, over DBpedia Spotlight. So the first version that we had was Lucene based. So you basically just take Lucene, you give in the text, and you let Lucene give you a score for how closely related this text is to the text that you've seen in Wikipedia for this specific entity. Now we have a new model which is a bit nicer because it's easier to internationalize. So with this model we created I think 11 language versions last year, and it works a lot better. So how this model works is basically we want to find the entity for a specific text that maximizes those 3 probabilities, and those probabilities are popularity knowledge. So we know in advance that some entities are more common than others. So for example, Berlin the city will occur a lot more often than Berlin the city in the US, for example. So this is the first kind of knowledge we have. The second knowledge we have is we know that how those entities occur as link texts in Wikipedia. So for example, Berlin is very likely to occur as just with the string Berlin, but for example, Michael Jordan would be quite likely to appear as Michael Jordan. He could also appear as MJ, but it's maybe not as likely. And the last knowledge that we have is context-based knowledge. So we have both in Wikipedia, we have a lot of words around the entity, and in our text we have a lot of words around the entity. So we just try to find the likelihood that the entity appears with these specific words around it. And we just put that together. We go through a number of candidates for each entity, and we select the one that maximizes those 3 probabilities, and that's basically how you can disambiguate for a specific text quite well which entities should be the correct one. Some more technical things. So we need to go through the entire Wikipedia dump, which is not that, I mean it is big, but I mean Wikipedia also does that, but we need to do some countings. We need to have some counts that are quite hard to get. So what we ended up doing is, in our latest version, we have the Wikipedia XML on the left, and then we give it into PicNLProc, which is a tool that runs in Apache Hadoop, and it's just a nice way of telling. We can just like in SQL-like syntax tell the system what kind of counts we want, and so the system collects all those counts for us, and we get the raw counts out in the end. So those counts are, for example, how often does the entity occur, how often does the entity occur with a specific word, things like that. And we take this, we take the DBpedia dumps, which in our case is only instant types, disintegration pages, and redirects, and we put that together in one system on a single machine, and then in the end we get one folder, which is like one model for one language. And we repeat that for like 10 languages, and that's basically what DBpedia Spotlight is doing. There are some challenges with that. So, I mean, the first thing is we need to do those counts on Apache Hadoop, because the most of the smaller Wikipedias are okay to do on a single machine, but with the English Wikipedia it's so huge that you just need to scale it up a bit. So this works quite well now, but the problem with that is, okay, now you actually need to have Hadoop to run the system, so we are working on making that a bit easier, because not everybody has a Hadoop cluster laying around. Yeah, but in the end what we want is we want to have a small model. So our model is entirely in memory, so because that way we can make it quite fast. But still we have to make it small, so what we had to do was like figure out ways how to get all of this data in small space. So for example, what you can do is, because all of the entities and all of the words in Wikipedia follow this nice Zipfian distribution, what you can actually do is you can squeeze the counts, which should be integers in general, into shorter size data types, so you can squeeze all of the counts into 2 bytes into shorts, which is quite nice. So that saves you a lot of memory. and then we had to do some serialization to make it fast to load the models. So at the moment this works. What doesn't work right now, which is still a challenge, is many Asian languages are problematic as well as Arabic, because if you look at German or English, for example, you have those words which are nicely separated by spaces, and sometimes you have to put the comma somewhere else, but the tokenization is quite easy. Now you want to do Chinese and you just have one long string of words, not even words, just characters. So you need to do tokenization first, find the correct words, and yeah, I mean there are tools for that. It's just not that nobody has yet tried to do that with what we're doing, but I hope that people will be working on that soon. So some recent additions to the project were that we added a support for Apache UEMA, so it will make it easier to use our tool for other tools. We also added support for the Google Mention corpus. So at the moment we are only using Wikipedia as our input, but Google released this big corpus of entities that they collected over the whole web. So now you can use the whole web basically as a training instead of only using Wikipedia. But then you need bigger clusters as well. So there was one of our Google Summer of Code students did that, and I think the last thing he ran was like 1/10 of the data, and it was already so much that it took forever. So so there are still some challenges with that, definitely. And there are some general improvements that we're working on at the moment. For example, if you want to tag stuff like Twitter, then a lot of the time the case is entirely over the place. Like people write either everything lowercase or uppercase, so that's a bit of a problem for the model, but that's currently fixed. And also we have some more advanced disambiguators. For example, there's a graph-based and a topic-based disambiguation algorithm, and also some code for dimensionality reduction. That was basically it. So to get started, there are basically two places. There is our demo page where you can try out the system with 8 or 9 languages and just paste the text and see what it does. And we have pre-trained models for English, German and Dutch and 9 other languages, which you can download at this website. And that's it. So now if you have questions, please.
Thanks.
Yeah. To your opinion, what's the main difference between tools from the Gate architecture and Spotlight?
Well, I mean, the Gate architecture has things like named entity recognition. I don't know if they have some things like named entity disambiguation. So, I mean, the thing is, the Spotlight basically puts everything together. So if you want to do this kind of stuff with Gate, you have to do your named entity recognition first, and then you have to do the disambiguation at another part. I don't know if there's an implemented tool for that. I don't think so. But yeah, I mean, those are like if you want a tool that does everything for you without you having to think about it, then Spotlight is probably the way to go.
Yeah, you have to distinguish between a special purpose tool like Spotlight or a Gate, which is a general architecture for text engineering, I think. You can do it. There are part of speech tagging, sentiment analysis, very generic.
Yeah, but what's also the case with us is that basically before you do anything, you should decide what you want to annotate. Because, for example, if you only want to do persons and organizations, then of course it makes sense to just use a tool that does exactly that and not something more general than that. But you can also tell Spotlight to only do that. So yeah, it just works the whole way.
What's the maximum text you can put into Spotlight?
Somebody ran some tests for that. I think it's like I have to look it up, but I think it's like 100 kilobytes or something. So I mean, it doesn't make sense to put in everything because internally we just chop it up as well. So you might as well run it a few times.
Stress testing, yeah. Yeah, I think also. Yeah.
So last year, Pablo and somebody else tried that, but one of the problems is that for this to work really well, this feature is necessary, and that's not yet merged. So I mean, it works, but it probably won't work that well because microposts are difficult. I mean, yeah, you need to really know. You need to be really careful with the case, because if your system relies too much on that, for example, that named entities are like written in uppercase, then that's a problem. But I mean, once this is merged, which should be in the next 1 or 2 weeks, this will be easier. But so far it works, but not great.
Are there any strategies on reducing model size right now? Because I'm using English and Dutch models, and in Dutch I have really no problems with the new version, good experience, but in English the model is just so great.
Yeah, I mean the English model is like 12 gigabytes or something at least.
Yeah.
So there are two things. One thing is this, what I said about squeezing the integers into shorts. That was not in the original version, so that's coming up. So that will reduce it by like maybe 30%, which is still not that much. But yeah, other than that, there's some work going on, but there's also a smaller version for English, which is like only 2 gigabytes, which basically ignores all of the context, which surprisingly still works quite well. But yeah, there's definitely some need to make it a bit smaller even for English, because also the discrepancy between English and the next biggest language is giant. I think, if I'm not wrong, German is the next biggest for our models, and English has like 12 or 13 gigabytes of memory, and German is already like 4 gigabytes, so it's like this difference is huge. It's mainly English that's problematic in this case.
Yeah, I think you also will be available in the last session, the I18N internationalization developer session. So Spotlight will also be part of this, because we are moving into other languages. Now the next presenter, Balas. Thank you again.
Yeah, make it. Okay.
I'm very strict with coffee breaks, you know. They're important. Yeah.
Okay. No, this is not great. Okay, I'm yeah, it seems like Greek for you, but it's not Greek. Okay. I'm Haralambos Koratsas Babis. You can call me Babis, it's more easy. And I'm from DBpedia Greek chapter from Aristotle University of Thessaloniki. Yeah.
Thank you. No, it's okay.
Okay. Yeah. From Aristotle University of Thessaloniki, and also from Open Knowledge Foundation Greek chapter. And I'm going to present you some work that we're doing in DBpedia Greece. First, all this. Yeah, but okay.
Let me be able to type.
Yeah. So,
Oh yeah. No, that's not too. I can go like this.
close. Sorry about that.
My first attempt.
So who we are behind the Greek DBpedia? We are people, we are still living in Greece. But of course, yeah, but of course we speak Greek. Okay? And we are professionals, academics from universities, and volunteers from Open Knowledge Foundation. And yeah. Yeah. Mainly from Lab of Medical Physics from Amsterdam University and Web Science Master Program and from Open Knowledge Foundation. And what we do, we collaborate with Wikimedia Greek community. We developed the Greek DBpedia and also the internationalization framework, and we try to internationalize some linked open data tools from DBpedia. And also we developed some useful, simple useful DBpedia showcases in order to show how DBpedia could be useful to the people. We collaborate with Wikimedia community in order to enrich the Wikipedia, the Greek Wikipedia content, and also the Wikipedia knowledge. We initiate an educational program, Wikimedia educational program in Amsterdam University, where involved more than 400 students from medical school and mathematics school, and we created or improved more than 200 articles, very good articles in Greek Wikipedia, which is, I think, important from DBpedia editions, not English one, but other DBpedia editions, in order to have more knowledge in DBpedia. Also, the Greek DBpedia was the first steps towards the linked open data internationalization, the first successful attempt to serve linked data to referenceable IRIs. I think Dimitris Kondokostas talked about that. We published the first linked open data cloud with DBpedia as a hub, and also we internationalized some existing tools like Finder and mapping tool, which provide a graphical user interface in order to create infobox mappings or to edit existing mappings. So our contribution to that tool was to make all this functionality available in other DBpedia editions. Also, we have the Greek DBpedia Spotlight. We developed the Greek DBpedia Spotlight, which is one first step towards the DBpedia Spotlight internationalization. And also we developed some simple useful cases. For example, an entertaining educational tool which consists a series of games as multiple choice, anagram, handcam, and other games. The novelty of this game is that automatically generates the question and answer through DBpedia Sparkle queries. The Day Like Today application, which informs the user about what happened a day like today in the past and presented information in a timeline. This end is the end back of the application. The user can choose here the DBpedia editions and the type of questions, for example, wars, birthdays, deaths, and all this. The Sparkle query for the war, the return data about the title of the fact, the date of the fact, the small description, the small thumbnail, and a large picture and related links in Wikipedia, in the related article in Wikipedia and DBpedia. Retrieve the results in JSON format and illustrate it in this timeline. Also, we published the library, the data of the public library of Varia in Linked Open Data Cloud, and we developed a search application to find an author and books and additional information from DBpedia. In Google Summer of Code, Lazarus Anidis has developed a DBpedia validation error power tool, which allows a power user to view aggregate information based on errors and their metadata. And finally, our most recent project is that we are still working on it is the basketball European data. We transformed all the basketball European league site, the data of this site in triples, and we store this in a virtuoso, and we try to link all this data with the DBpedia. We have all the seasons from 2001 till now, and we want also to have a timeline with statistics, with players, with all the basketball story. That's all from Greece. I think I'm in time.
Yeah, you're good. You're good.